Alright, so we are doing our exponent notes. Starting out, it says blank are numbers being multiplied. So numbers that are being multiplied are called factors. So in the two examples that they give us, 6 times 3 equals 18, and 2 times 3 times 4 equals 24. 6 and 3 are both factors. And 2, 3, and 4 are factors. $18 and $24 are not factors. $18 and $24 are called products. So when your factors are the same, you can simplify it by writing it with an exponent. The base, B-A-S-E, is the number being multiplied, and the exponent tells you how many times to multiply the base to itself. So in the example, 6 times 6 equals 36. 6 is the number that's being multiplied, so it's our base, and our base is the big number. 6 is multiplied twice, so our exponent is 2. So 6 squared, so what that 2 means, equals 36. Same thing over here. We have 2 times 2 times 2 times 2 equals 16. Well, 2 is the number being multiplied, and it's being multiplied 4 times. So 2 to the 4th power is 16. Expressions that use a base and an exponent are called powers. So we have 6 squared. The 6 is our base, and the 2 is our exponent. But all of this together, the 6 and the 2, this is called a power. And 36 is still called a product. So I've been doing it just a little bit, but we need to also learn how to say these things. So we talked about the 6 to the, and with an exponent of 2, being squared. So if we have 5 with an exponent of 2, that would be written as 5 squared. Then if we move on and we have, let's say, 8 with an exponent of 3. Anytime you have an exponent of 3, it is called cubed. So this would be 8 cubed. Then beyond 3, it's called to that power. So for example, if you had 3 with a 4, it would be 3 to the 4th power. Or if that 4 was a 5, it would be 3 to the 5th power. If that 4 was a 10, it would be 3 to the 10th power. Okay, so then they also tell us down here that any number raised to 0 is 1. So I want you to underline that. I squiggly underline. You can underline however you want. Any number raised to 0 is 1. So they give us the example 2 to the 0 power equals 1 and 10 to the 0 power equals 1. A lot of you guys will ask me why, and you don't have to write this down, but I'm just going to give you an example very quickly. So if we have 8 squared, that means 8 times 8. If we take that down to 8 to the first power, that is just 1/8, because essentially what we have done is divided by 8. So if you have 8 to the 0 power, that would be 8 divided by 8, which is 1. Now you don't need to know this right now, but you will in your next math classes in 7th and 8th grade especially. You can even go to the negatives. So since we were dividing each time, now you also have to, if this was a -1, you would do 1 divided by 8. So 8 to the negative first power is 1/8. So that's just a piece of information for you to have. Okay, and just like in that example, it kind of explained, any number raised to 1 is itself. So for example, 3 to the first power is 3, 140 to the first power is 140. Okay, so let's do some more examples. Okay, for some reason, this did not copyright. It shouldn't say 24, so if you'll mark that out, it should say 2, and our 4 is our exponent. So in word form, this is 2 to the 4th power. So that means 2 times 2 times 2 times 2, which 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. The next one is 4 times 4 times 4. So that's 4 being multiplied 3 times. So that's 4 cubed. So 4 times 4 is 16. 16 times 4 is 64. Okay, the next one just gives us standard form, which I didn't tell you before, but standard form is just when everything is solved. Okay, it's kind of like our answer. So with 25, I have to think of what's a number that I can multiply to itself, maybe twice, maybe 3 times, maybe more, to give me 25. Well, this one's kind of easy. If we take 5 and multiply it to itself, that would give us 25. So that would be 5 with an exponent of 2, which is said 5 squared. Okay, the next one says 6 cubed. That means 6 times 6 times 6. 6 times 6 is 36. 36 times 6 is 216. Okay, then we have 625, and this one can be a little bit difficult. So if you want to pause and think for just a minute, you can. Since it ends in 5, we like to start with our 5s. So just on the side, I'm going to experiment a little bit. 5 times 5 would give me 25. So we know we need to go farther. So 5 times 5 is 25. Times 5 more would be 125. So what about 5 times 5 times 5 times 5? Well, 125 times 5 gives us 625, which is what we needed. So we can write that in there. This is 5 times 5 times 5 times 5, which is 5 to the 4th power. Now there are also some other acceptable answers. If we look at 5 times 5 times 5 times 5, we could have said, well, 5 times 5 is 25, and this 5 times 5 is 25, and that would still give us 625. So you could have also said 25 squared. Or, if you got real creative, you could have said 625 to the 1st power. Okay, so the last one on this page says, is 2 cubed the same as 3 squared? Justify your answer. Okay, so I've got to think about this. I know that 2 cubed means 2 times 2 times 2, which that equals 8. And 3 squared means 3 times 3. That equals 9. So is that the same? No. All right. Moving to the next page. It says the formula for area of a square is A equals S squared, where S represents the side length. Find the area of these squares. Okay, so we've got A equals S squared. S is our side length, which for this one is 6 inches. So A equals 6 squared. I know that 6 squared means 6 times 6. So A equals 36 inches squared. Circle our answer. Okay, the next one is 3 centimeters, so same process. A equals S squared. So A is going to equal 3 squared. 3 squared is 3 times 3. So A equals 9 centimeters squared. Okay, so the next one says, try these on your own in pencil. I want you to do it in pencil because sometimes we mess these up. So if you would like to pause the video and do these on your own, that would be great. That's what I want you to do. I want you to try them on your own. I'm going to also do them so that when you come back, you can check them. Okay, hopefully you have tried these on your own. You paused the video and tried them. I'm going to go over them quickly of what the answers should be. So, this one is 7 squared. That means 7 times 7, which is 49. Next we had 4 times 4 times 4 times 4, so that's 4 to the 4th power. Oops, ran out of room. Which should be 256. The next one is 8 cubed. which is 8 times 8 times 8, which is 512. The next one was 125. The only answer I found for it is 5 cubed. Which means 5 times 5 times 5. I guess you could have also put 125 to the first power. Okay, then we have 10 times 10 times 10 times 10 times 10, so that's 10 to the fifth power. I like this little trick with the tens. The exponent tells me how many zeros to put behind my 1. So I've got 1 and then 5 zeros. 1, 2, 3, 4, 5. So our answer is 100,000. Our next one is 10 cubed. So that's 10 times 10 times 10. Which is 1,000. Okay, for 32. Once again, you could have said 32 to the first power, but hopefully you thought about it a little more in depth than that, and you got 2 to the fifth power. So that's 2 times 2 times 2 times 2 times 2. All right, the next one was 6 to the fourth power. That gives us 1,296. The next one is 5 to the first power. Which is just 5 and 5. All right, then we had 3 to the fifth power. Which is 243. Okay, so it says to solve, so that means standard form. 8 to the 0 power is 1. 12 squared is 144. And 7 cubed is 7 times 7 times 7, which is 343. Then find the area of the following square. We know that the formula is A equals S squared. So A equals 5 squared. That means 5 times 5. So A is 25 centimeters squared. The last one says, a square has an area of 121 centimeters squared. What is the side length? Okay, so we have A equals side squared. Now they're telling us our area. So 121 equals S squared. So I need to think backwards. What number times itself would give me 121? Another way I could say this is the square root. What is the square root of 121? The correct answer would be 11. So 121 equals 11 squared. So the side length would be 11 centimeters. Now don't put squared behind it because our side length isn't squared. our answer was squared, our area, but not our answer for the side length. Okay.